Okay, friends, so I got a little confused. It's a little late in the evening, and so I had to rewind, and that's why you have two videos here, and that's why some of my work's already done. So I'm going to try to back up. I'm going to show you where I made my mistake and see if you can catch it. So we're on number 5 here. And when we were doing this in class, I noticed that a lot of you were trying to get rid of the decimal. The only time that you have to do that is when there is a division problem and the divisor has a decimal. That's the only time that you have to worry about getting rid of a decimal. In multiplication, you can have a decimal with as many with as many place values after it as you want. And so I'm going to show you how to do that. So you just come over here and you set it up like a regular multiplication problem. Now, this lines up nicely because each of them have 2 digits in them. If they do not line up nicely, you do not have to line up decimals when you're multiplying. You only do that with addition and subtraction. So my recommendation is if you have a number that has 3 or 4 digits and one that has 2 digits, you just put the 4 digit on top. You just make it look like a regular multiplication problem, and you don't have to worry about those decimals until we get to the very, very end. So here, I went ahead and I started my multiplication. I said 7 times 8 was 56. So I could put my 5 up here and my 6. Now I had 7 times 6 was 42 plus 5. That gave me 47. So then I was done with my 7. So I came over to multiply by 9. Now 9 is in the tens place. I'm really multiplying by 90. And since 90 is a multiple of 10, I'm going to put my 0 here. Because anytime I multiply a number by a multiple of 10, there's always going to be a 0 at the end. It's not a placeholder. It has a purpose. It's because we're multiplying by a multiple of 10. Now I take 9 times 8. I'm going to cross this 5 out because I've already used it. I take 9 times 8, and that answer, that product, is 72. 9 times 6 is 54. Does anybody see where I made my mistake? I hope you notice I forgot to add my 7. So 54 plus 7, that gives me 61. So then my final answer is 695. Oh, great. Another great example why we don't do math with an ink pen, and that is a 6. So 6596. Now, Ms. Pipkin, you have decimals in there. You're right. And so now I'm going to go back and I'm going to figure out where to put my decimal point. I'm going to come back up here to my original problem. Here's a decimal and there's a tenth. Here's a decimal and here's a tenth. Now, if I multiply 10 times 10, what do I get? 100, right? So if I multiply a tenth by a tenth, I would get hundredths. So I want my decimal to reflect tenths, hundredths, okay? The other way that I can look at it, the cheat way, or the more efficient way, is that here's a decimal, here's 1 place, decimal 2 places, so I have to put my decimal in 2 places. So my answer for this one is 65 and 96 hundredths. All right, again, I apologize for all this working ahead here. So then for E6, this has division. That's the first thing I notice. So divide, no decimal, okay? No decimal. So I'm going to set it up as a fraction. A divided by B is the same thing as A over B. So I notice that in my divisor, I'm dividing by tenths. So I want to get rid of that. I need that to be a whole number. So since it's in the tenths column, I'm going to multiply by 10, top and bottom. And that not only gets rid of my decimal down here, but it also gets rid of my decimal up here. And so now I have 42 divided by 7. And my answer to that is just 6. All right, and then I had no decimals, so I don't have to worry anything about that. All right, number 7 takes us into the world of PEMDAS. All right, now I know a bunch of you all were thrown because of these fancy parentheses here, okay? Don't be scared of the fancy parentheses. It's just, it might look like those, it might look like this. It could even possibly look like a gigantic bar like that, like it's caging it in. So it doesn't really matter what it looks like. They're just all parentheses, okay? And what you do is you start on the inside. You go in as far as you can go and you start working your way out, okay? So because I'm going to start here, everything else stays the same. And I'm going to carry it down so I don't lose my place. That stays the same, that stays the same. Now I'm solving right here. 3 times 2 is 6. That stays the same. Now this part's in parentheses and that's what I'm going to solve. So my 8 stays the same. 14 take away my times. 14 take away 6 equals 8. My 4 stays the same. All right, so I've done my parentheses. I didn't have any exponents. Exponents is when you have like those little numbers that look like that up at the top, and we don't have any of those, so I don't have to worry about it. Now I'm coming down to multiplication division. This does not mean that you have to multiply before you divide. What it means is multiplication and division come next. So it's like you're reading. So you start all the way over here on this side of the number sentence, and you're looking for multiplication symbols and division symbols. The first thing I come across is a multiplication symbol, and it is 8 times 8. So I'm going to go ahead and I'm going to solve that, and I get 64 divided by 4. And then I can go into my long division. 64 divided by 4 is 16. So I didn't have to do this first. I didn't do this first because it was multiplication. I did it because that's what order it came in my number sentence. Same thing with addition and subtraction. You just look for those symbols and the numbers on either side, and that's what you're going to solve. But you have to work it left to right, just like you're reading a book. All right, number 8. A block of cheese that weighs 5 pounds is divided into 8 equal pieces. How much does each piece weigh? All right, so if I have a whole of 5 and I break it into 8 pieces, each of those pieces is going to weigh 5 divided by 8, okay? Of a pound. Because that's what we've done here. We've taken this 5 and we've divided it into 8 pieces. Or 5 divided by 8, which is the same thing as 5 over 8. So each piece would weigh that. And I could check that. I could say 5/8 plus 5/8. That'd be 10, 15, 20, 25, 30, 35, 48ths. Which is, guess what? 5. Okay? So this would be my answer, 5/8 pound. Now, how many ounces would each piece weigh? Okay, so I know that there's 16 ounces in 1 pound. Whoa, I'm just making up my own symbols tonight, 1 pound. I have 5/8 of a pound. So, I'm going to go ahead and I'm going to multiply 5/8 of 1 pound, 16 ounces. That's what I want it to be. 16 ounces is the same thing as 1 pound. So I've got 5/8 of a pound is how much each piece weighs. I'm going to do that cross simplification that I talked about earlier because I see right away 8 goes into 8 1 time, 8 goes into 16 2 times. Now, my number is much easier to work with. 5 times 2 is 10 over 1, which is 10 ounces. If I didn't, I would say 6. If I didn't cross simplify like that, I would say 16 times 5 is 80 over 8. And that would also give me 10. Okay. So If you have any questions, go back and watch it again. Listen really carefully. Write the answers down yourself. See if you can make sense of it. If you can't, we're here to help you. Just raise your hand. And you guys are going to rock out this test. You just have to believe in yourself. You have to slow down. You have to think about it. And you have to come prepared. You know these tests are going to be longer. You know they're going to require a lot of thinking. So come into the test with that mindset, friends. And you are going to rock it out as mathematicians. Good luck.